Okay, so now they give us the graph, and we're supposed to come up with a possible equation. I did it a couple different ways, and yeah, it can be slightly different, but I'm going to make some points about that. So we have the graph, there's the picture. Find a possible equation for the common logarithmic function. Now that's important because that tells you the base is 10. Okay, so let's get our basic form of a function here. Kind of easy to remember because it goes A, B, C, D, right? Okay, so the easiest way to do this is to look at the horizontal shift first. And you're going to find that on the asymptote, based on the asymptote. So the asymptote looks like it's right here at x equals -2. And that means that c then is 2. Okay, so it shifted left 2, so c is equal to 2. We'll fill that in. Now, because it's a common log, I know the base is 10. Forgot to mention that. So b is 10, so I can just write log x plus 2 plus d. So we know b because it was a common log. We know c based on the vertical asymptote. And now we just need to find a and d. So we're looking for two variables. The points that we're going to use this point right here. And that point is -1, 1. Okay, so in other words, if we put in a -1 for x, we're going to get f of x, or y, to be 1. So 1 equals a log, let's see, we're putting in a -1 for x. Okay. So we get 1 equals a log 1 plus d. Okay, now you might say, well, that's not going to do me much good because I don't know a and I don't know d. There's something special though about log 1. So log 1, this is like a side note over here. What does that equal? We'll say it equals, I don't know, give me a letter we haven't used, h. Okay, well then if you were to rewrite that in logarithmic or in exponential form, it'd be 10 to the h equals 1. So what does h have to be if we're going to get 10 to some power to be 1? H has to be 0. And so we make this statement that log of 1 equals 0. Okay, so we're saying h equals 0, so that means that common log of 1 equals 0. It turns out that it doesn't matter what the base is, and that's a property, and we're going to talk about the properties, I believe, in section 6.4. So those will come up. But we're going to say this right now, that log of 1 is equal to 0. That means now I have 1 equals a times 0 plus d, or 1 equals d. Okay, so now we know d. All right. So now my new and improved equation says f of x equals a log x plus d. I'm sorry, that's supposed to be a 2. X plus 2 plus 1, because we just found d. Okay, so now we need to find another point that we know so we can plug it in and find the value of a. Now, you're gonna ask me questions, I just know. I'm gonna use the point 2, -1. That's the one the book uses. Now you might say, well, why don't you use 0, 0? I did that on my own, and it works out to be the same value, which I want to talk about at the end. But for our writing purposes, we'll just use this point 2, -1. And again, this is x and f of x. Okay, so we're going to plug that into our new and improved equation here. F of x is -1. A, we don't know. We're trying to find that out. The x we're putting in is 2. And so we get a statement like this. Okay. If I subtract 1 from both sides, I get negative 2 equals a log 4, like that. And now if I divide by log 4 on both sides, then I get a to be, these cancel, negative 2 over log of 4. Okay, so I want to talk about this just for a minute. It's kind of a long video, but this right here, this is just a number. You can put it in your calculator. Just plug in negative 2 divided by log 4. And you're going to get approximately negative 3.32. It's just a value. There are no variables in this part right here. That is just a real number. And a lot of times students get confused on that because it looks so weird. They're thinking, oh, there's a variable in there somewhere. But it's just a real number. It's an irrational number, but it is real. Okay, so we have found a value for a. So our final answer is going to be, if we take from here where we had C and D already filled in, but now we're going to plug in A. We're going to have negative 2 over log 4. And that whole expression there is the value of A. It's just a value. We don't put in the negative 3.32 because that's rounded off. So this is an exact value when we write it that way. Then it's going to be log, it's a common log. Let's see, what was it? X plus 2 plus 1. So that's going to be our equation, or one possible equation. Now, let's see. I did use 0.0 when I was finding A, and it turns out to be the same thing. When you use that, you get the same. It looks a little different, but the value is still about negative 3.32. Oh, the other thing I was going to mention, we are expecting a negative value for A because it's reflected about the x-axis. This is in the picture, I'll scroll up. In the picture, this was a decreasing function, right? Decreasing. So we were expecting the value of A. The value of A should have been less than 0, and it is. Okay, so there you go.